This example is asking you for a vector u to be defined by a directed line segment, and they've given you the coordinates. And they say if u equals AB, with the column AB, find A and find B. So first thing, there's two ways that you could do this problem. The first one is sort of more geometric graphing way, so I'll do it that way first. So we've got the point 2, 6, which is 2, 1, 2, 3, 4, 5, 6, that's there. And we're going 2, 3, 1. So we're going over to 3 and up 1. So we have a vector which is going from 2, 6 to 3, 1, and that particular vector is called u. Now if you're doing this in a more geometric way and you want to actually graph the thing, what you can do then is you can actually see straight away what your distance is going down and what your distance is going across. So you can see the distance here going down is 5, 1, 2, 3, 4, 5, and the distance going across is 1. So for A and B, this vector u would be defined as 1 across because we're going that way, so this is positive in the x direction. We're actually going this way down though, so this is negative in the y direction. So we've got positive 1, I might make my column a bit bigger there. We've got positive 1 and then going down 5, 1 minus 5. Now the other way you can do this is to look at it using what are called position vectors. Now position vectors start at the origin O and they go to a particular point. So for example, if you were given a point A1, A2, okay, that would be defined as if you wanted it to be a vector going from O to A1 across, so that would go in your column, and A2 would be going up, so that would go in your column as well. All right, so we can think about this in a different way, and I'm just going to copy this picture here so we can use it on the next page. So this vector has two parts. The first part here was this point, which was 2, 6. I'm actually going to draw this now as a vector going straight from the origin. Okay, 2 to 6. So that particular vector there, I'm going to call this vector, just call it A. So A is a vector that goes from the origin across 2 and it goes up 6. So that's A, given as a column vector. I'm also now going to draw another vector to the end point here, and I'll do that in, let's do this in purple. So I'm going to start at the origin and go across 3 and then go up 1. And I'll call that vector vector B. So vector B is a vector that goes across 3 and then it goes up 1. Now if we wanted to go from this point here, 2, 6, to this point here, which is 3, 1, we'd have to travel in this direction down u. So if we think about constructing u using A and B, you can see that we'd have to go from this point backwards along A, so u would be given by negative A, and then we'd have to travel all the way along that vector till we got to the origin, and then travel back up this vector, which is B. But we'd actually be travelling in the correct direction for B, so we can keep that as a positive sign, positive B. So to get from this point to this point, we'd travel backwards along A and then up this way along B. Using the columns, we'd be travelling negative A plus B. And if we're going to be adding and subtracting column quantities, I'm just going to take that negative inside here into both. Oops. When we add and subtract in columns, all we do is literally put the things on the top together. So negative 2 plus 3, they're the x's, and you've got negative 6 plus 1 going together at the bottom. Negative 2 plus 3 is 1. Negative 6 plus 1 is minus 5. And we know, looking back again, that we had 1, negative 5 for u, and you can see here we've actually got exactly the same thing. U equals 1, negative 5. What we've ended up doing is using position vectors that go from the origin, as it's stated here, to a particular point. So for that point 2, 6, we can construct that as a position vector from the origin, and for 3, 1, we can construct that as a position vector from the origin. when you're looking at points, and let's say here we were going from that point 26 to that point 31, what you'll find always happens is if you're going to define these as position vectors, so maybe as A and as B, you always travel backwards down the first vector or position vector that you're going to have. And that's because you need to get back to the origin to start on the next position vector to get where you want to be. So we had to go backwards on that A to get to here. So you could straight up have looked at this as well, alternatively, and just thought, okay, I'm going to have to travel backwards along that. So that would be traveling -2 in the x direction, and -6 in the x direction, in the y direction. And then I'm going to travel +3, and I'm going to travel +1. So I'm going to end up at 1 and at -5. Okay, so either way that you think about it, the key thing here is you can either do these questions geometrically, or you can break them down into position vectors, so vectors that go from the origin. Think about these coordinates simply as columns. So instead of writing it as 2, 6, write it as a column 2, 6, and write your second one as a column 3, 1. And when you're looking at that distance or that vector that's constructed from these two, always subtract the first one from the second.